Trigonometric derivatives. These 6 formulas are absolute must-know. The derivative of sine x is cosine x. The derivative of cosine x is negative sine x, derivative of tan x is secant squared x, derivative of cot x is negative cosecant squared x, derivative of sec x is sec x tan x, derivative of cosec x is negative cosec x cot x. Notice the beautiful pattern. All cofunctions, that is cosine, cotangent, cosecant, get a negative sign in their derivative. On the graph, see how cosine x, shown in green, is exactly the slope of sine x at every point. Example. Find the derivative of y equals sine x plus 2 cosine x minus 3 tan x. Apply the sum and difference rules with trig derivatives. Derivative of sine x is cosine x, derivative of cosine x is negative sine x, multiplied by 2. Derivative of tan x is secant squared x, multiplied by negative 3. Final answer, cosine x minus 2 sine x minus 3 secant squared x. Inverse trigonometric derivatives. These are critical for G. Derivative of sine inverse x is 1 over root of 1 minus x squared. Derivative of cosine inverse x is negative 1 over root of 1 minus x squared. Derivative of tan inverse x is 1 over 1 plus x squared. Derivative of cot inverse x is negative 1 over 1 plus x squared. For sec inverse and cosec inverse, the formula has modulus x times root of x squared minus 1 in the denominator. Key pattern, the derivative of sine inverse plus derivative of cosine inverse always equals 0. This is because their sum is always pi by 2, which is a constant. Same for tan inverse and cot inverse pair. The graph shows how 1 over 1 plus x squared is always positive and peaks at x equals 0. Example. Differentiate y equals tan inverse of 3x minus x cubed over 1 minus 3x squared. This looks complex, but there's a trick. Substitute x equals tan theta. Then the expression inside becomes 3 tan theta minus tan cubed theta over 1 minus 3 tan squared theta, which is exactly the triple angle formula for tan 3 theta. So y equals tan inverse of tan 3 theta, which simplifies to 3 theta, that is 3 tan inverse x. Now differentiating is easy, dy by dx equals 3 over 1 plus x squared. This G-favorite trick simplifies dramatically using trig identities. Logarithmic differentiation. The derivative of natural log x is 1 over x, for log base of x, it's 1 over x times ln a. The powerful chain rule version, derivative of ln of f of x equals f prime of x divided by f of x. The logarithmic differentiation method is used when the function is too complex for regular rules like x raised to the power x, or products and quotients of many terms. Step 1, take natural log of both sides. Step 2, simplify using log properties. Step 3, differentiate both sides. Step 4, multiply by y to isolate dy by dx. On the graph, the green curve is 1 over x, the slope of ln x at every point. Example. Differentiate y equals x to the power x. Neither the power rule nor exponential rule works directly here because both base and exponent contain x. Take natural log of both sides, ln y equals x times ln x. Differentiate both sides using chain rule on the left and product rule on the right. Left side gives 1 over y times dy by dx. Right side, derivative of x times ln x, using product rule, gives ln x plus 1. Multiply both sides by y, which is x to the x. Final answer, dy by dx equals x to the x times open bracket ln x plus 1 close bracket. Exponential function derivatives. The derivative of e to the x is e to the x itself. This is the only function that is its own derivative, making it incredibly special in mathematics. For a general base a to the x, the derivative is a to the x times natural log of a. With chain rule, derivative of e to the f of x is e to the f of x times f prime of x. On the graph, at any point on e to the x, the slope of the tangent equals the y value itself. At x equals 1, the value is e, and the slope is also e. Example. Differentiate y equals e to the sine x plus 2 to the x. For e to the sine x, apply chain rule, e to the sine x times derivative of sine x, which is cosine x. For 2 to the x, use the a to the x formula, 2 to the x times natural log of 2. Final answer, e to the sine x times cosine x, plus 2 to the x times ln 2. The chain rule for composite functions. If y equals f of g of x, then dy by dx equals f prime of g of x times g prime of x. In Leibniz notation, dy by dx equals dy by do times do by dx. Think of it as a pipeline, x goes into the inner function g, producing u equals g of x. Then u goes into the outer function f, producing y equals f of u. The chain rule says, multiply the rates of change at each stage. The mnemonic, differentiate the outside function, keep the inside unchanged, then multiply by the derivative of the inside. This is the most important differentiation rule for G. Example. Differentiate y equals sine cubed of 5x squared plus 3. This has 3 layers of composition. Outer layer, something cubed, derivative is 3 times something squared. Middle layer, sine of something, derivative is cosine of that something. Inner layer, 5x squared plus 3, derivative is 10x. By chain rule, multiply all 3 derivatives together, 3 sine squared of 5x squared plus 3 times cosine of 5x squared plus 3 times 10x. Simplify to get 30x sine squared of 5x squared plus 3 times cosine of 5x squared plus 3. Remember, each nested layer adds one more multiplication in the chain. Implicit differentiation. Sometimes y is not explicitly written as a function of x. Instead, x and y are mixed together in one equation, like x squared plus y squared equals r squared, a circle. You cannot easily solve for y alone. The method, differentiate both sides with respect to x. Crucially, every time you differentiate a y term, multiply by dy by dx because y is implicitly a function of x. This is the chain rule. Then collect all dy by dx terms on one side and solve algebraically. On the graph, see the circle. At every point, implicit differentiation gives the slope of the tangent. Example. Find dy by dx for x squared plus y squared equals 25. Differentiate both sides with respect to x. Derivative of x squared is 2x. For y squared, use chain rule, 2y times dy by dx. Right side, derivative of 25 is 0. So we get 2x plus 2y times dy by dx equals 0. Solving, 2y times dy by dx equals negative 2x. Therefore, dy by dx equals negative x over y. We can verify, at the point 3, 4 on the circle, the slope is negative 3 over 4, which is indeed perpendicular to the radius exactly as expected for a tangent to a circle. Key exam tips. First, memorize all 6 trigonometric and 6 inverse trigonometric derivative formulas. They appear in almost every calculus problem. Second, e to the x is its own derivative, simplest ever. Third, chain rule is the most frequently used rule in JEE, master it completely. Fourth, for functions like x to the x, always use logarithmic differentiation. Fifth, in implicit differentiation, never forget to multiply dy by dx whenever you differentiate a y term. Sixth, sine inverse plus cosine inverse always equals pi by 2. Seventh, for complex inverse trig problems, simplify using substitution before differentiating. Eighth, always check domain restrictions for inverse trig functions. If you found this helpful, like and subscribe for more JEE and board exam solutions at MAGPIEHUB.